everybody! 6.6, property of the kites and trapezoid. That's what we're going to be doing today, and I hope you've got your thinking caps on because this one has a lot of theorems in it. And they're theorems that have very little to do with parallelograms because the shapes are not parallelograms. So get your notebooks out and get your thinking caps on. Alright, the first shape we're going to look at is a kite. A kite is a quadrilateral, and it has exactly two pairs of congruent consecutive sides. So the congruent sides are next to one another, like so, instead of across from one another. Okay? So you've got two sets, and the opposite sides are not going to be congruent, just the consecutive ones. Alright? Moving right along. Now we have the theorems. Yay! Okay, the first theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. This one's pretty simple. If it is a kite, then the diagonals will form a perpendicular intersection right around here. It's going to have 90-degree angles attached to it, and this will always happen. If it is a kite, it will always have that perpendicular diagonals. Alright, moving on. Number 2. This one is just as important, but maybe a little bit harder to remember. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Not can be one, not will be at least one, it will always be and only be one set of angles, and they will be opposite angles, okay? Because otherwise, it will be a different shape, okay? So if D and B are congruent, then A and C cannot and will not ever be congruent, okay? So it has to be one, it will always be one, and it will always be only one, alright? Now that we have the kites out of the way, I hope you picked up on a couple of those theorems. I was going kind of fast. Sorry, there's a 15-minute timestamp, and I'm trying to keep this as concise and helpful as possible without running over and rambling. Okay. Here we go, moving right along into the trapezoids. A trapezoid is a quadrilateral, it's got four sides, with one pair of parallel sides. Instead of two, it's got one. And they are the opposite ones, okay? They are called the bases. This is important, they are the bases. The non-parallel sides, excuse me, the non-parallel sides, the ones that aren't parallel, because definitions, are called the legs, okay? They're highlighted in red here, alright? The angles, okay? Two angles, like so, that are attached to the same base, so they're connected to the same base, not to a base, but the same base, are called base angles, okay? Now, the legs of a trapezoid are congruent. The trapezoid is an isosceles trapezoid. And forgive me if I say isosceles triangle sometime in this recording. It's a trapezoid, okay? Theorems. And there is much rejoicing. Yay. Okay. If a quadrilateral is an isosceles triangle, going back to them, then each pair of base angles, the ones sharing the same base, are congruent. So isosceles triangles have congruent base angles. Easy to remember, incredibly important, okay? Number 2, if a trapezoid has one pair of congruent base angles, like so, at least one identified pair, then it is isosceles, okay? And just my 2 cents, if you know that these base angles are the same, and this is isosceles, then you kind of also know that these are the same because of this theorem. Just saying. Alright, and the third theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So in any other trapezoid, these angles can be any length they want in comparison to any other length. But in isosceles, they're not. They're the same. So BD and CA, they are equal. Okay? They will always be equal if the triangle trapezoid is isosceles. Okay, let's go on and find some examples that aren't at the beginning of the textbook, shall we? Alright, now we've reached the mid-segment of a trapezoid. Okay? This is a funny little thing. It's not like the mid-segment of a triangle. Okay, so we have the trapezoid mid-segment theorem. A mid-segment of a trapezoid is parallel to each base, and the length, so this length, is half BC plus AD. So the bases, you add them together, and divide them by 2 to get x and y, okay? BC plus AD over 2 equals XY. Alright, short little theorem, hard to remember. Moving on. Practice! Alright, here's where I'm going to want my handy dandy little whiteboard here, and we're going to pull up our handy dandy Google calculator because I can't show a regular one on my computer. Alright, so let's find an example, shall we? Let's start with, this is a new computer, so that kind of stuff is going to pop up. Alright. How about, alright, here we have some kite applications. Alright. In kite, W, X, Y, Z, in measure of angle W, in kite, this is the kite. Measure of angle W, X, Y, so this angle right here, this whole thing is 104, okay? And measure V, Y, Z, so this little itty bitty angle right there is 49. So we're gonna close our eyes and point our mouse around and go with number 5. Okay. So find measure V, X, W. Okay? Oh, right. Simple enough. So we know that V, Y, Z. So we know that this angle right here is 49. And we also know that these angles are congruent, and by the reflexive property that Vy and Yv are congruent. So we know, and we also know that these are congruent, and these are congruent, and these are both 90 degrees. So basically we know by side, angle, SAS, we'll go with SAS, that this is, these two are congruent. This angle is 49. Okay? So we have 49 and 90. So we're going to take our handy dandy calculator, and 49, again, new computer, 49 plus 90 equals 139. So we have 139, but we got to get to 180. So we're just going to subtract 180 minus 139. We're going to get 41. So let's take a look. This angle YXV, is 41 degrees. However, problem, they're asking for angle WXY, or VX, they're asking for VXW, okay? VXW, they're looking for this angle. And since we know that this whole thing right here is 104, we can do the magic of math and subtract 41 from 104. Oopsie doopsie. And we get 63. And you know what? We have the magic of math on our side and find that this VXW is, drumroll please, 63 degrees. Okay? So to recap what happened, magically, we know this angle. We know this angle. Scrap that. B, Y, C. Okay, scrap that. We know this angle. We know this angle and this angle. So we translate this. So by SAS, we know this angle. So we make that 180 and find this angle. So we track that from 104, because this angle right here is 104. And we just subtract. Okay? Got it? Sorry, I'm moving a little quickly. Again, we're on a little bit of a press for time. Trying not to overrun my boundaries here. Okie dokie, artichoke. Hey, look, a trapezoid problem. Alright, so since these are ML and PQ are congruent, and MP and LQ are congruent, so this must be, because it has two sets of congruent sides, that it must be an isosceles trapezoid. Okay? And this is a base angle to this angle. because they both share the same base. So we know that MPQ is 118 as well. Okay? We also know that this all must equal 360 because it's a quadrilateral. So we're going to do this on our handy dandy thingy-majooger. So we're going to do 118 times 2. I do a little dot but it doesn't look like anything. Equals this just really wants me to download that, doesn't it? So we're going to get that to be 236. Alright, so we have 236. Hunky-dory, except for that doesn't answer our question. We're looking from this angle. Alright, so we know that since we have 236 and we're trying to get to 360, that these angles divided by must be the key to the 360. Alright, so we're going to subtract 360 from 236 from 360. To equal 124. And you know what? Do you know what we're going to do now? We're going to divide by 2 to get 62. So measure of angle Q, magically enough, is 62. And why we divide it by 2, that's the important part here, because these two are base angles in an isosceles triangle. They are equal, and therefore we must divide the remaining by 2 to get equal numbers for these two. Alright, let's find a Alright, 22. Find KR. KR. Alright. So we know that we only have a couple minutes left, so I'm gonna go a little bit faster through this than maybe you'd like. But, you know, we'll get it done. Alright. We have JT and KR divided by 2 equals 52.5. Okay? So we'll do that. 32.5. We'll make this an equation. 32.5 plus x over 2, because we had to divide it by 2 to get that final number, equals 52.5. So we're just going to solve this equation. So we're going to multiply this by 2 to get 105. Alright? Then, just to get that final number, we're just going to subtract 32.5. Alright? So, we're just going to clear that. So we have, cancel. What am I doing? We have 105 minus 32.5. That's the end of our equation. So we're just going to get our handy dandy calculator here because I don't have the time to do this in my head. And we're going to get 72.5. It's a really... So, we set up for this problem. We're going to... Sorry, people. This is a new computer. It's trying to get me to download some apps and some security systems and some searching things that get it all set up. But I don't know if I want to do that yet, so that's just going to keep popping up. I really am sorry about that. Okay. So anyway, we're going to get that KR is 72.5. And how we got that? We set up an equation. Since we knew that 32 plus this number divided by 2 would equal 52.5, we set that up as an equation and solved. Okay, so what you do is you do the equation to find the middle number, but you do it backward. It's like reversing the theorem. That's basically what it is. It's pretty simple. Yeah. Alright, so I hope I went over everything. I wish I could have gone a little bit slower, but the time crunch. And sorry about some of the computer glitches. This is new to me. So thank you guys so much. And ask your teacher if you have any questions, or come see me. I could probably try to explain it a little better. And, well, I guess I'll see you next time I make one of these. Alright, bye!